So good afternoon, my name is Marc van de Hofstadt Serrano, and I'm here because I want to show you my PhD work done up to now, where we have been seeking to image living individual bacteria at the nanoscale with the Atomic Force Microscope. So why this eager for this goal? As you may know, bacteria is one of the most exploited organisms in our world. But due to their small size in the micrometer range, the study of individual bacteria is very complex. For example, this image shows an individual bacteria, but this bacteria is dead and is covered with a conductive metal in order to be detected. So we need living bacteria. For this reason, we use the Atomic Force Microscope. This technique, which has been briefly explained before, has the ability to do images under liquid condition. So this will allow us to do images of living bacteria in physiological conditions. This technique is very easy, actually. It's like Braille. You follow the roughness of the surface, but since we want nanoscale resolution, we will need a nanoscale finger, where a laser will use in order to detect the deflection of this finger. So the first step will be image dry bacteria to get inhabit. So for example, this is a dry dead individual bacteria where we can see that the blue line shows the cross section and the height of this bacteria is only of 240 nanometers, which is very small because we're expecting 1 micrometer of height. So this image shows the result from a living dead analysis kit, which allows us to distinguish living from dead bacteria, where we can see, as expected, all bacteria are red, shown by the red dye. So we know that we need to do images under liquid conditions to obtain living bacteria. So the problem is the adhesion on the bacteria, onto the substrate. We use physisorption. This method relies on the electrostatic attraction between the bacterium and the substrate. But as you can see, although it could be a weak attraction, it is non-invasive since it's bacteria's natural way of adhesion. A problem, which is directly observed, is the possible electrostatic repulsion between the substrate and the probe. Since we want high resolution, this repulsion, which could be up to hundreds of nanometers, must be very small. So after hard work and try to find a break-even between the attraction of the bacteria to the substrate and reduce electrostatic repulsion, we can actually image living individual bacteria. Here, for example, we show two images of living Escherichia coli, very common. The first one, for example, is a conglomerate of this bacteria, where we can see the different lengths, where the smaller one has just undertaken division. On the right, we see more separate individual bacteria, which are sitting flat on the substrate. Since we obtained the topography, we can actually do cool stuff, such as 3D representations of these images, where some things like the unions between the bacteria can be seen much better. So repeating the previous test of viability, we see that with a high percentage, the bacteria are alive, shown here with the green color, compared to the previous that were all dead, shown in red. So another method to corroborate this bacteria were actually living is the cross-section. Here we see in the black showing the living bacteria, and in red showing the dead bacteria, where we obtain the micrometer range expected, compared to the dead bacteria, which are 1/4 smaller in size. I'm going a bit too fast, sorry, it's the nervous. So what's our next step? Our group, where I am at the Institute for Bioengineering of Catalonia, is specialized on the nanoscale bioelectrical characterization, where our work we can actually calculate the dielectric properties of biomembranes and of lipids under liquid conditions. Also, another cool stuff we can do is actually predict if a virus has DNA or not in its interior. So following on with the previous work just shown up to you, we would like to know if the bacteria, the living bacteria, can be extracted some internal characteristics using the electrical characterization. Thank you very much, and don't hesitate to ask any questions afterwards.